CES, or Consulting Engineering Services. I'm going to drown you in acronyms today because the industry itself has tons of acronyms. So CES is in Middletown, Connecticut, and we design systems primarily for the built environment. I just wanted to, well, Nicole left, but I was going to thank her for putting all this together because I know it's not an easy feat. So I'm going to dive right in because I know a lot of you might not be aware of the MEP industry or the building industry. And I wasn't either, but honestly, once I was introduced, I was really attracted to the diversity and creativity of the field. So our hope today is that this diverse panel of speakers can really get you excited about the built environment, and maybe it will encourage you to get involved. So I'd like all of us to just, I know you just got off the bus, just take a moment and take a deep breath and think about how you're feeling right now. Are you hot? Are you cold? Do you need water? Do you feel awake and ready to participate? So the systems that this panel designs and incorporates into buildings, they're not meant to be seen or heard, but they bring comfort to their inhabitants. So every building you're in, you might not notice what's going on in the background, but fresh air is being pumped into this room right now, which affects how awake you are and how able you are to pay attention. It affects your health. So clean air, water, fire protection, air conditioning, they're all vital organs of every building, and they contribute to your well-being. Humans are a lot like buildings, and so buildings have several internal systems that all connect together and affect the operations, just like our internal organs. They also, like I said, can have a really positive effect on humans and the environment, and I know everyone on this panel is constantly looking for opportunities for a more sustainable future, and we could do that through the systems in our buildings. So being an engineer in the built environment, it also allows an opportunity for a lot of collaboration. What goes into creating a building are not only the MEP engineers, but you work with architects, construction managers, structural engineers, civil engineers. They all come together to create a building like you're in today. Being an engineer in the building industry, you're exposed to so many different trades that it really does open up the possibilities for your career and can take you in several different directions. Okay, so Nicole put together a slide that just kind of exemplifies that. So this kind of shows where some of us on the panel today fall in the organization of how a building's made. So say there's a public opportunity, just to be easy. An RFP will come out, a request for proposal, and an architect will respond and a general contractor will respond. So it needs to be designed and it needs to be built. Engineers always typically work for the architect in a new construction building, and that could be, like I said earlier, mechanical, structural to civil. Just as on the CM side, the CM is gonna put what the engineers have designed out to bid to all of their subcontractors. And what we have represented here today are our reps or our vendors who have all of the equipment that they're speccing for the building. Is that correct, guys? Right. Okay, so without further ado, I'd like to introduce the panel. I would like everyone to take their time to introduce themselves, and also it would be interesting to hear how you got into the industry. Go ahead, Jacqueline. Sorry.
I'm Jacqueline. I'm a project manager at UConn Heating and AEC. We're a mechanical contractor, so we install the HVAC systems. I got into this, so I started out actually as a manufacturing engineer in the automotive industry, and I really liked collaborating with people, and I kind of wanted to go into a more sales kind of mode. I kind of just fell into HVAC, and I really like it because every day is so different. There's so much to learn in this field. So like I'm constantly learning every day, and not every day is the same. I feel like that fast-paced kind of challenge every day. It's a great field, and that's how I got into HVAC.
So I'm Laura Murata, the Director of Building Automation Sales for Environmental Systems Corp. I've been with the firm for 7 years. And originally, so in college, I played sports, so I wanted to be in a team environment. I like to be people-facing, talking. So that's where I knew I wanted to be on the sales side, very similar to you. But also wanted to use my engineering skills. So when I went to, when I was about to graduate, I used our career development center, and they helped me pick a, role that would be nice, good for me. So that's where I got recruited by Carrier, which is a HVAC equipment and controls company, and that's how I got into sales, and I used their program. So I really enjoyed working with my team, like a sales team and the operations team, to implement building automation. Does anyone know what building automation is? Okay, all my friends don't know either. So think of a thermostat, right? That controls heating and cooling equipment, so similar to what Jackman's company installs and Mitch's company provides. So we turn that piece of equipment on and off. So think of a big microprocessor computer chip that controls bigger systems. So it's just a really very robust thermostat, is the way to think of it. But think of that throughout at a college like UConn or a hospital. So that's what we do.
My name is Brad Huff. I work for Salas O'Brien. We are a consulting and engineering firm, similar to CES. So we specify the building components for contractors to bid on and build the building instead of set of construction documents. I got involved in the field. I'm a graduate of UConn, so coming out of UConn, there's a big UTC presence, Pratt & Whitney, Otis Elevator, Sikorsky. And I think what drew me to the industry was similar to what Jacqueline was saying. So there's quite a few projects that you work on simultaneously. You're not focused on an individual component of a larger design. So, for instance, I've been with the company for 13 years. I've worked on 220 plus projects. I told it up before coming here. So it's fast paced. You get involved with a lot of buildings around the state. It's nice. I'm able to drive through the state. My wife gets annoyed with me because I point out different buildings that I've worked on, and point out the rooftop units which nobody looks at. But it's enjoyable to work on a project. So yeah, exactly.
Hi, my name's Mitch Joseph. I am a recent hire with Mitsubishi Electric, Train USA. We're a collaborative team with Train, where we help assist owners, engineers, architects on understanding how and where to utilize our technology into their buildings, whether it's a house, like a building of this magnitude, educational facility. We try to help them understand where the best equipment, where it makes sense to use that style of equipment. I am not a UConn grad, went to University of Hartford right around the corner, but my career path also went to Warren. I played sports in college. I played soccer at University of Hartford, and I wanted to be in that team collaborative environment. So I jumped into HVAC right out of college, or in an MEP firm down in Norwalk, where everything was just streamlined from there. In sales, I had that opportunity to speak to lots of different people, different customers on a day-to-day basis, and just like Brad and like CES, you have that ability to, your every day is different, from trying to solve different issues or problems based on a particular building structure, and just find new ways to skin a cat kind of thing. So.
I'm Brittany. So I work for CES, Consulting Engineering Services. I'm a mechanical engineer, so I design HVAC systems, sprinkler systems, plumbing systems within large commercial buildings. I call on Mitch quite a bit to help me with some of my HVAC equipment. And I am a UConn grad, so I graduated in 2020, so 3 years ago. I really enjoyed my time there, and how I got into this industry actually started back in high school. So when I was a sophomore in high school, we had a AutoCAD class. If any of you have heard of AutoCAD, it's a software where you can draw parts and you can draw buildings and stuff like that. We had a teacher that was an architect in her previous life and that got into teaching. And I just really enjoyed drawing on the computer and drawing different buildings. As a senior in high school, one of my projects was designing my dream home. So kind of from that point on, I got into college and wanted to get into this industry because I got a taste of it in high school. I'm a pretty creative person, but I also am much better at math than I am at drawing. Like architects, they're pretty impressive. And so that's how I found my way into this industry.
My name is Sean Michael Parkinson. You guys can call me Sean. I work for Consigli Construction, so if you want to build a house, you're not going to build it with your hands, but neither are we. We get the people to actually go out there and build it and make sure that they're doing it right to however you guys want it. Actually, I don't know if somebody could read that poster on the wall in the back right. I actually think that's the building I'm currently working in. Does that say George Street on it? So yeah, funny enough, that's the building I'm working in. We're doing a couple things in there. We're renovating one of the roofs. So my job is making sure that if you want to renovate the roof, I got to make sure that the material that you're using is right. I got to process that paperwork, make sure that the architect says, yeah, that's the material we designed for you guys to use. And that's my role. I make sure that the schedule is in place, taking all the meeting notes. I'm basically a glorified manager because there's the manager that actually deals with the money side, but I help with make sure everything's organized and on check as to what you guys want to build. I'm a UConn grad. I graduated last year, so last week was my first year anniversary at Consigli. And how I got there, it's been quite the journey. I literally went into college knowing I wanted to do something construction related, but I didn't know the opportunities, like the exact job opportunities that fit to my interest. And it kind of just took some trial and error. I went out and did some carpentry, working with my hands, building fences, renovating houses, and I was like, this is too much. So I tried going behind the computer, and I was a bridge designer at one point for STV in Hartford. So doing a little bit what she does, I was using AutoCAD, using the blueprints behind the computer, but I still was like, my legs were kind of jittery. I wanted to get up still. So I was like, this is still not it. And even going into my senior year, I still didn't know where my head was set, and just heard about the field called construction management. It's, getting your hands dirty without getting sweaty, I guess. It can get stressful, which might cause you to sweat, but other than that, it was kind of like the perfect in-between between being involved but not being overworked, in my opinion. So I honestly didn't even know what the job entailed. Job descriptions are so extensive, and sometimes they're still kind of vague. But I just took a whim, and project engineer is my role, and being that glorified assistant in construction management, where you're just making sure everything goes how it's supposed to go. And it actually turned out to be the perfect fit for me, so I got lucky. I've been lucky since.
I bet you get to see a lot of cool buildings. And actually, that's something that I noticed as all of you were speaking. We all have very different roles in the industry, but there's common ties. I'm just wondering, before we go to the next question, if each of you could just talk about or just mention one or two of the buildings that you're working on right now so that the group can understand the diversity that this field touches. So you were saying
Yeah, so not only am I building that, we're building a parking garage at Sacred Heart, but for your knowledge, we were going to, I don't know if we got it, but we were going to build those new South dorms at UConn. We're going to build those. What else did we build out there? Just so many. Sometimes it's as little as renovating a room, but we were going to try to get the South dorms, but it seems that they changed their price, so I think it might be still up in the air.
So I work on quite a variety from schools to public safety, smaller lab working renovations. One school project that I started on right out of school doing the plumbing and fire protection design is Oakley High School in Hartford. And now that's just starting construction now and doing coordination drawings. So that's gonna be probably like a 6-year long project where I have, I just completed design for a fire station in Bloomfield. And that was about a 4-month design process. And it's scheduled to be done next fall, so it'll be constructed within a year. So you can really get a wide range of timeframes in terms of how long the design process takes as well as the construction. And being on the design side, we're heavily involved in design, and then during construction we get to go out and we answer questions from the CM, and we check up on the design and make sure things are getting installed right. So it's really cool. You get to see the project from start to finish, and it's really exciting when it's done.
So the projects I've worked on, they're driven by the MEP engineer, the consulting engineer. So whether it's a library, a large grow facility where they're growing either lettuce or marijuana within a facility, dormitories, music labs. So we're collaborating with these guys based on what they bring to the table to assist them with what they're looking forward to designing.
Yeah, so me right now, I'm working on a wide variety of projects that are active, from laboratories to higher education projects. Some projects at UConn, Yale, Quinnipiac. We go to University of Vermont. We've got a hospital up in upstate New York as well. 2 projects that we're wrapping up in CA right now. We have a project at Electric Boat. It's a 140,000 square foot manufacturing building, and what they do, the role of the building is when they're building the new submarines, this one building assembles one of the, I think it's 6 modules that kind of slide into the hull of the submarine. So they've got this in the assembly area, a massive mega door, which is 60 feet tall to roll in the module, and they build it in there. And then they've got the Navy in other parts of the building where they're training the sailors to go off with the submarine. So that project is wrapping up in CA right now, but it's a cool one to be involved on. And then our other major project in construction right now is at Yale. It's actually in West Haven, but it's right near the Yale football bowl. We're renovating the football team's locker rooms and training facilities down there. So it's a historic building. I'm sure if you guys are familiar with it, but it's a cool project to be involved in.
What's it called?
Yale Lab.
Yeah.
Oh yeah, so I was gonna mention that, I'm glad you just spoke up. So we are working on that with Consigli. So some of Sean's colleagues, I'm involved with Corey. So the building industry it's a very tight industry. We all have connections across there.
If it leads into me, I'm actually working with a lot of projects, a lot of people on the panel. So we're actually working with Sean over at 300 George Street at multiple vivarium lab spaces, some air handlers and lighting projects there. We work with, mechanical contractors such as UConn down at, I think we just finished Tiptree, which is an office fit out. But we get to work with projects designed by mechanical engineers, and we also do a lot of owner direct. So right now, does anyone see the new ice rink at UConn? So we just did the control system there. Actually came out really, really nice. And then we also do owner direct work where at Mohegan Sun, we're replacing the chiller plant controllers, which provides cooling to 1 million square feet plus facility. So that was an owner direct where we did the layout. So we get to work with and work on buildings, from diverse as hospitals, colleges. I think with Brad, your team are working at Trinity College, redoing their hot water plant. So what's nice about what I get to see, I get to work with a lot of people here, like I talked about before, being in a team environment. Even though we're not at the same company, we all have to work together to get that end product. So when you get to walk by a building that's completed, it's definitely a team effort and great to see.
like everyone else, I'm working on a wide variety of projects from big to small. So one of my bigger projects right now I'm working on is Stanford Hospital. We're redoing an entire floor for the maternity floor. So those big projects are usually designed by, they hire an engineer to design it, so we have to follow a construction set of documents. And like smaller projects, like I'm doing another restaurant down in New Haven, it's very small. They don't even hire an engineer, so we have to kind of design the whole HVAC ourselves. Because a lot of times when they switch out different customers, like a restaurant sells their restaurant to someone else, they sometimes change the layout, so like the airflow has to be different, so we have to figure all that out. So that's kind of what I was pointing at earlier, how everything's different, and you have to kind of have a wide variety of knowledge and be able to kind of problem solve to figure out how to fit certain HVAC solutions to whichever, task you're given.
So I know you guys are just embarking on your college career, which is gonna take you down many different paths. And I think the same goes for your professional career, as you're hearing from the panel today. There's many different paths you can take. I'd like to hear from the panel what you thought you were going to do when you graduated college. We can start with that.
I thought I was going to be a manufacturing engineer. I was actually in college for industrial engineering. I had no clue what I wanted to be, even my senior year, so I kind of just took like the first job that I came across, and in industrial engineering, all they talked about was manufacturing. So I kind of thought that was for me, but it ended up kind of being a little mundane for me. Every day was the same. I was looking at like the same piece of metal every day, and I kind of just wanted something different, and just started doing job searching, applying for any sales job I could find in the technical field, because it was kind of working with people. And so then I got a sales job in HVAC, selling kitchen equipment and designing kitchen ventilation equipment. And then it's all about networking, because then I met with a bunch of different mechanical contractors, and I met the company that I'm with now, and they kind of provided an opportunity for me to work for them. And I decided to go to this company because it provided me a much bigger range of knowledge. Before I was just focusing on equipment, but now I'm focusing on the equipment and the aftermath of after you sell the equipment and how to install it and what the unit actually does in the space.
So when I graduated, my senior year, my career as a DJ wasn't going to pan out. So I actually went to my career development center, and I kind of talked about what I wanted to do and what industry. I wasn't sure, so they kind of had set up some interviews for what I want to do, and talk to those companies. And like I mentioned, when I talked to Carrie, it was a good mix, because I was going to be using my engineering skills, but also be able to drive and meet customers and talk. I'm a big talker. And so that sounded great to me. And then part of that program was when I graduated, they had a 6-month program where graduates from other colleges, so I went to school in upstate New York, from like California, Alabama, we all got together in Syracuse. So we had 6 months of getting to know each other, and we were all taking that same path of starting our careers. And actually have those friendships today, and we still talk. So learning about what Carrie did in building automation controls really intrigued me, and like Jacqueline said, every day is different. My day is, it's always a new problem to solve. There's multiple ways to do it. So, which for me is, I don't have the mundane. This is what I do every day. Every day is different. Yesterday I was in New Hampshire. Tuesday I was in West Hartford. So I'm all over the place, which I like. So I get to work from home, and then I get to travel throughout the state in Western Massachusetts.
So, if you were going to ask me this question when I was in high school, I had absolutely no clue what I wanted to do. I went into college for engineering, and I was hesitant whether engineering would even be the correct fit for me. I was going between landscape architecture, physical training, and engineering, so absolutely nothing to do with each other, right? And I just figured, let me see if engineering works for me. I had my own hesitancies whether I could make it through the program, which I'm sure some of you guys probably are nervous, scared. It's a tough program, right? You'll get through it. But as I made my way through college, I still wasn't sure what my career path was going to be. Do I want to go into automotive design? Do I want to go into the building industry? A lot of my friends were going to Pratt & Whitney, UTC. I kind of fell into this industry, being honest, and I stuck with it just because I saw path to work, and I enjoyed it. I enjoyed the fast-paced movement of industry. So I was really unsure even all the way through graduation. Yeah, that's the honest truth about that.
So, I myself in high school, I had an uncle who was an electrical engineer for Sony for quite some time, so he was constantly traveling between Connecticut and Japan, and I liked the idea of doing that. And my father was, or still is, a automotive technician, so I got to see a lot of different components come together, whether it's a camcorder or a DVD player, which no one uses anymore, or fixing a car from it being completely demolished to making it look like it's pristine again. So I thought I was going to jump into the automotive industry. So I did CAD in high school, CAD throughout college, and decided I wanted to go into engineering. Mechanical was probably the better fit for me because I liked math. So I stuck with mechanical engineering, graduated, still had no idea what industry I would actually get into, because all the automotive jobs that I wanted to take on were either too far from home or just wasn't the right fit. So stayed local and got into the MEP consulting world, where I helped design houses and large buildings, and now jumping into I'm in a sales role where I get to assist engineers with problem solving of their facilities. So it's been a good transition, for sure.
So I kind of made my way into the industry back in high school when I got into that AutoCAD class. I also have family in the industry. My father's on the owner side, so he is a facilitator for 5 hospitals up in the North Shore of Massachusetts. And then I have a brother who is older than me. He is a construction manager for a general contracting firm in Massachusetts as well. So they're on different sides of the industry than I am, but I kind of knew about the industry. And so since I really enjoyed AutoCAD, they suggested I kind of looked towards getting into it. And so when I got into UConn and I knew I wanted to take that path and wanted to get involved, I found some professional organizations I could get involved in as a student. So I got involved in NEHES, which is the New England Healthcare Engineering Society. And with them, I formed a student chapter at UConn. So you guys have a club at UConn called Healthcare Engineering Club, where they practice designing buildings. They go through different scenarios and how to design. I think this past year they did like a maternity suite for a healthcare building and some cool ideas there. And then they go and they present and come to professional organizations, conferences and whatnot. So that's how I kind of got involved at an early stage in college. And then from there, I was able to do a couple different internships. And I did all my internships with design firms, but I have been now at 3 different firms through internships and now where I work currently. And I think one important thing with picking a career path, it's not necessarily what you do, but also who you work with, and kind of the environment you want to be in. So, it doesn't necessarily, a lot of times it doesn't necessarily matter what you do as long as you're really happy with the people you're with and you're in a great culture, and you kind of enjoy every day. I work with some of my best friends, so I think that is something to look forward to. And as you guys start to get into internships, as you apply for jobs, really ask about culture. Really take the time to talk to people when they walk you around, and just try to get a feel for, do I fit in with this group and do I want to be here?
So yeah, coming out of high school, all I knew was that I wanted to be around the concept of building stressful at the time, you know, your parents hammer you over the head, like, you know, get into school, you know, choose your major, make sure this is done, and at the time I almost like kind of felt rushed, and my process was literally just looking up building, and civil engineering was the first thing that came up, so I pursued civil engineering throughout college, and you know, I just try to get different experiences, from completely working with my hands to completely being behind a computer to, you know, design blueprints for whether it's bridges or whether it's like mechanical devices as like a phone. And then even coming out of school at that point, I still didn't know what I wanted to do. But I've come to learn the best way to put it and how to figure out what you would like to do. It's two things. It's what you like to do on the day-to-day, like what you're comfortable with doing on the day-to-day. I didn't like working with my hands all day, nor did I like being behind a computer solely all day. So my current job is being behind a computer, but also like walking down and making sure that they're doing it right. So that was my in-between for what I wanted to do on my day-to-day. And then the other part is what type of concepts do you like being surrounded by, whether it's mechanical, electrical, whether it's computer science, whether it's animals, whether it's really just what you like to do on your day-to-day and what you like to be surrounded by. And if you can find that in between, you'll understand what opportunities are, you know, realistically out there for you.
All right, I'm gonna do one more question, then I wanna take a little pause, and if you guys have any questions for the panel, that would be the time to ask them. And of course, you can stop me along the way. So I just wanna do a little deeper dive into your college careers and understand, what did you study in your undergrad that helps you today in your profession? And also, if you don't mind getting into some of the responsibilities in the nitty-gritty of your day-to-day.
So,
Go ahead.
yeah. So, honestly, it's really funny. I don't really apply much of the concepts that I've learned in school. But that's as realistic as it gets. Obviously, because essentially I'm the person that reaches out to somebody that does what I used to study. Like, if somebody here was a civil engineer, I wouldn't do the actual math calculations. I would reach out to them to make sure that, you know, they would do it and then come back to tell me that, okay, it's good. And then I tell the person who's out there working with their hands to, you know, proceed as necessary. But it gives me great context. It allows me to be smart in conversations with what I've learned in civil engineering between steel, like a lot of the steel is what I learned in college, and you know, reading blueprints and identifying what makes sense. It helped speed up that process. So it was very contextual. But in terms of applying, I honestly don't even do much calculations in my day-to-day. Whereas in school, it was just literally all numbers. But at the end of the day, it really is just problem solving. So that also applies to my day-to-day.
Yeah, along with what you said, I'm going to take differential equations. You will never need to know how to do a differential equation if you work in any of our companies. But those classes will push you to learn how to problem solve, which is absolutely critical for any of the companies we work for. So you may not actually be doing those exact calculations day to day, but problem solving is extremely important. So you'll learn how to do that. You know, if you're struggling on a homework, really push yourself to struggle, and then, you know, use your friends, figure out how to find the answer, work together. We all work in team environments, so learning how to work with your peers and solve problems together, it can be really rewarding, but also very applicable to what you'll do in your career. Learn how to do research. I can't tell you how many times I get tasked with something that I have no idea what to do, and they're like, well, here's the code book, figure it out. And, you know, if I ask questions, they'll answer my questions, but, you know, they really challenge you to problem solve, figure out how to do things. and how to do them correctly. So, I encourage you to research, use Google. You're all very smart, very tech savvy, so research, problem solving. You'll even, it's even important to be organized and, come up with a good method for taking notes. This will help you in all your classes, but also when you get into the industry, we sit on a lot of meetings. We all sit on Zoom calls, we all go to sites, and taking good notes is critical as well, because you never know if you make a design decision today, and then when your building starts getting built in 2 years, and they're like, why did you make this decision? You can go back to your notes and be like, this is why we need to do it this way, or, oh, the contractor is right, they have a better solution, we should do it their way. So it's extremely important to learn how to problem solve, learn how to be organized, take notes, and just, work with your friends and be a team.
Completely agree with everything Brittany just said. From collaborative, so I still, on a day-to-day basis, I still have to know how to collaborate with engineers, contractors, owners on how systems work. So having a open, candid conversation, and being up to speed with some of the codes that they use as well, so that way I can know how to steer a conversation, and collaborate. And if they're going to teach me something I don't know, I'm going to teach them something that they could use that'll work in their benefit, right? So calc 1, 2, 3, I don't use any of those. Differential equations, do not use, will never use. But thermodynamics, machine design, that stuff I still need to know, because I even talk to the engineering team on my end that I need to collaborate with and see if we can work around a piece of equipment to make it work for the construction team, the design team, make sure everything is cohesive. And if it doesn't, I'll let them know, hey, we have an issue there. So being able to problem solve, collaborate are big key items, and being open to change, and understand that there are different ways to make something work is the bigger key. It's not one right answer. There are a multitude of ways to get to that answer, and whatever works in your benefit, run with that.
So I went to UConn from a mechanical engineering degree. Mechanical engineering is a broad field, so I would say half of my classes probably had no relevance. Well, not no relevance, but I don't use in my day-to-day. But there are specific classes that the concepts I use every day. Specifically heat transfer and fluids. Those concepts for a mechanical engineer, HVAC designer are important in our field. But I think it's the stuff that you learn in college that is not necessarily course-based or textbook-based that is probably the most important in our field. And I'm going to echo the same thing you guys both said. Problem solving, communication with your peers, collaboration. So you'll see UConn will have you do presentation work, a lot of presentation work to get out in front of people. And it's uncomfortable, but becoming comfortable being uncomfortable is important. Also teamwork kind of goes along with the collaboration aspect, and note-taking and prioritization. It always seems like exams fall on the same week. The teachers don't talk. You'll probably have 3 exams during the same week. The same thing happens in the real world, where you'll have 3, 4, 5 deadlines in the same week, and you'll have to prioritize your time and make the most of it to get it done. So it's that stuff that I found important during school that I learned. Life skills, like this.
Or maybe they are talking.
Or maybe they are
Yeah.
talking. Yeah, they might have been.
Here's your
But
three-
it
here's
sure
your three
felt like it
tests.
sometimes. Yeah.
So I was an electrical engineer. I graduated from Rensselaer Polytechnic in upstate New York. So just like everyone else is talking about, it's all about problem solving. And I don't use like differential equations or calculus maybe here and there, but light amount. But the biggest thing that I learned, especially in college, is group projects, how to work together, 8, maybe 10 people. I mean, I had a class that was like 25 of us, and we had a manufacturer, actually made like soap dish, and, but how to get people all on the same path, same goal, and making sure everyone's pulling their own weight, that was big. And the other part I know Brittany talked about is research. Finding outside. For what I do every day is talk to someone who knows more than I do. And to create, to solve a problem, right? I deal with a lot of customers, they have this issue, and I don't have all the answers. One of the biggest thing is, like, if I don't know the answer, I'm gonna find someone who does and bring that to the customer. That's the biggest thing. You could not know an answer for what we do. Find the person who does and bring that person to the table and bring that information to help solve. That's the biggest thing. And when I was in college, trying to have all the answers, I think reaching out to TAs, professors, upperclassmen, or people in your class, utilize those people in your community that can give you those answers. So that was key, probably me my junior, senior year, and then I use that every day for what I do. I reach out to, manufacturers, engineers, contractors, probably that's my day-to-day, tons of emails. But, and the biggest thing is problem solving, listening to your coworkers, listening to the customer, that's key. And you're gonna listen to your professors and take that information and put it to notes and put that to action.
Studied industrial engineering at Penn State University. I think the biggest thing that you learn in any engineering field is, like everything else, like collaboration. And I think communication is so important because you work with so many different personalities and different people. You have to be able to know how to communicate with each kind of different personality style. I think like 98% of the problems happen because people aren't communicating with everyone. No one's on the same page. I think a lot of that can be avoided by just letting people know what's happening, and you can learn that through like team projects. Because like a lot of the times you hear like all the time, oh, someone's not pulling their weight. It still happens in the real world. Like it still happens in our lives too, and you have to kind of understand how to deal with that in a way where you're not like forcing someone to do something. It's just kind of navigating different personality types. And I think communication and networking is so important. You get a little taste of networking in college when you go to like these business events. And I didn't realize how important it was back then, but it really is important. It's a lot of times it's connections that get you throughout your professional careers.
Okay, does anyone have any questions for the panel at this point?
I'm sorry, it kind of blew over my head, but what is floating?
So, none of us, everybody looking at each other, because none of us actually work for Flowtech. Flowtech hosted this, right? But Flowtech is, they're a product representation firm. So they are specialists in air handlers, lab equipment. So, for instance, my firm would reach out to Flowtech and we would say, hey, listen, we need to install an air handling unit in a brand new building. But myself and our firm, we just know we need an air handling unit that needs to be an X size. We don't actually build the physical unit. So Flowtech is the medium between us and the manufacturer of that unit. And they're the sales representative, I guess is probably the better way to look at it. So we work with them to get on our drawings what we need, size of the unit and so forth, but they're the interface between us and the factory. That's my definition of Flowtech. Some others might want to add on to it.
How many people in this room are going into mechanical engineering? What other majors are in the room?
Civil.
Electrical, what's that?
Civil. Robotics engineering.
Robotics. What'd you say?
Chemical.
Chemical engineering, okay, cool.
Our field touches all those industries. If I want to do a clean agent system for fire protection, a clean agent system is a chemical that is released into the space that reduces the oxygen and sucks the oxygen out of the air so the fire cannot grow and then dissipates. I do not make clean agent. The formula we're using now is like Novak 1230. That's something that a chemical engineer somewhere in the manufacturer is designing that and coming up with that. A hot topic in our industry right now is refrigerants. We definitely need chemical engineers to solve that problem for us and come up with a refrigerant that is healthy for the environment. You know, the refrigerants we're using currently have a high global warming potential, so that's hurting our ozone and creating greenhouse gases. So, you know, the chemical engineers are a critical component in our industry. You know, civil engineers, we work with them all the time. From a MEP standpoint, we have to coordinate all our sanitary, electrical, and fire protection services to a building and figure out inverts and how to coordinate that. And you have, you know, electrical engineers. I sit in a cube with electrical engineers, and, you know, as soon as we start a project, they're like, I need to know all the electrical information on your equipment, how big my service needs to be, how big my generator needs to be. So even if you guys all got into our industry and we're all a part of different companies, you would still talk to each other every single day. And you would all have very different, unique perspectives in doing different things, but you could not build the building unless all of you are in the room and a part of the project. So I think that's one really unique thing about this industry is it really takes, you know, hundreds, thousands of people to touch one thing to build a building. So.
Thanks, Brittany. That was very well said. So to the panelists, I feel like we touched on the next couple of questions, but if you have anything additional that wasn't said, please just start talking. So aside from engineering, are there any qualifications and skills needed to be successful in your position? I know we've talked about communication, public speaking, being able to work in groups, and definitely problem solving. Was there anything else, like a soft skill that you weren't prepared for as you moved into your career?
Technical writing is a big one.
Oh,
Because there will be an instance where you have to write an email to someone, and if you don't relay that information correctly, they could read it completely different and really botch how something was supposed to be handled. And just picking up a phone and having a conversation. Sometimes communication is lost through email and or through text. So just picking up a phone call and just having a conversation with someone, being open and honest is key. People can read through how you relay that information improperly and take it the wrong way or take it offensively. So just having a conversation over the phone just puts all that to bed. But also following up with the email, just make sure everyone's on the same page and it's documented is a big critical thing to it.
For what I do, especially in the sales side, is presentation skills. You know, be able to, you know, talk in a meeting, be able to present ideas, and be able to utilize PowerPoint or any other program like that to present to a group. I think that's very key and a good skill. I know during my college career, you got to do a lot of presentations that will help you get ready, but that's definitely a skill that you need on the sales side.
great. I think we kind of touched on this question, but let me know. What other job positions do you interact with regularly, and maybe how did they, those interactions shape you as a professional? I know we talked about, Brittany just kind of laid that down. Anything we missed?
I mean, I feel like I work with, actually, no, I can't say that, but I do work with a very diverse group of people. Because, you know, I'm given the task of building something, but I'm not an expert in each division that requires something to be built. Like, for the lights, for example, making sure that they're the correct, I forget what the term is. Yeah, I'm not an expert in that, so I have to go to an electrical engineer and ask them the question. Same thing goes for the air distribution. I'm not an expert in that, but I gotta make sure I know I ask the right questions, because they're knowledgeable enough. Same thing with the sprinklers. I'm not an expert in that, but I gotta ask the questions to make sure that the answers are, you know, answered. Kind of just it's like, honestly, just looking around the room, you see what different parties play into what makes a room, from, you know, the drywall to the carpet on the floor to the, you know, the wiring in the room, it all just comes together, and you essentially end up working with a lot of group of people.
I can't draw lines on the monitor, but if I could use one of my projects as an example right now, I'll use the Yale Fieldhouse there, which is kind of Sean's company. But so I kind of lie in the engineering sector here, but we work for an architect on that project, which is Epsilon 1. And Epsilon 1 interfaces with Yale. Yale has a project management group. They're typically architects or engineers in their project management group. So every day I'm talking with the architect. I also interface directly with Yale. I'm talking with, well, not specifically on that project, but I would talk with Mitchell and Lauren about equipment on that project. And then when the project goes into construction, we're talking with Sean, who's the GC, CM on the project, and then he has mentioned they make sure everything gets done correctly on that project. So he has a whole bunch of subcontractors, mechanical, electrical, plumbing, and you'll interface across with those subcontractors. So on a day-to-day basis, I mean, that's really happening on a day-to-day basis. I'm touching base with everybody. Sometimes it's meetings with everyone in there. Sometimes it's a large one. So it goes across the board. And then we also do internal in the office. We're also working with marketers and on the business side. So it goes across.
Marketers and piggy writing, like
Yes.
Mitchell loves. Anybody else? Okay, so Brittany, you touched a little bit on refrigerant and sustainability, but I'd like to hear from the panel. How does your role in your company work towards making the built environment more sustainable, efficient, and environmentally friendly? What is the hot button now? We can start with.
So one thing, we're building a fish research lab in that building in there in the basement. And its goal is to be eco-friendly. So like, from the carpet to like the walls, they have to be made out of materials that are, recycled and stuff like that. So some buildings nowadays more than less take the approach of like using products that are eco-friendly and recyclable and overall green. So that's how my role kind of touches on being eco-friendly and sustainable.
Have any of you heard of the term net zero? You guys know what that means? So net zero is a big goal for many states and for a lot of firms and companies. And basically what we're trying to get to is that the amount of energy a building consumes versus how much it produces equals zero. So that way it is not impacting the environment from an energy usage standpoint. There's a lot of different practices that go into making a building net zero, from the mechanical HVAC standpoint. We're putting in extremely efficient systems. So you might start to hear terms like geothermal, heat recovery, and systems like that. And then from the electrical side, you might just start to hear about solar panels and EV chargers and things that really, solar panels that can harvest energy for the building. And so we're really being pushed towards creating these very efficient buildings that at the end of the day have a net zero energy input. We're not putting a burden on our grid, and it can be self-sustainable in the future. So our team's doing a lot with geothermal. I'm assuming that you know what that means. Basically, they drill a well about 500 feet down to the ground. There's a tube filled with water or liquid, that goes down into the well and back out. The ground is great, for retaining heat. So in the winter, it heats our water. In the summer, it cools our water. And then that is used to cool and heat the building. So we are using the ground to cool and heat the building rather than gas or electricity. We're using practices like air source heat pumps. So again, we're now using the air and we're extracting the heat out of the air and putting it into our building, or we're taking the heat out of our building and extracting it from the building and putting it back into the air. And that is a basic refrigeration cycle or reverse refrigeration cycle. And you'll learn about that in your thermodynamic classes. So a lot of principles that you'll learn with the cycles and thermodynamics come into play when we're trying to do energy recovery and whatnot. So that's how we're getting involved.
From the sales role or from the Mitsubishi realm, our system, they drive for high efficiency, so there are various standards that are required to build or regulations that direct you on how efficient your system needs to be to install into a new building or in a renovation. So we work with the engineer directly. We will, so our systems are, there's a COP, which is a heating criteria that stands for coefficient of performance. So the higher that value is, it starts at 0. So 0 means that it's sort of a wash. But as you go higher, it means that you're putting 1 unit of energy in and you're getting X amount out. So you can get 2, but you can be a coefficient of 2. That means that you're getting double the amount of efficiency out of your equipment. So we're working with the engineers directly to make sure that they have that guidance to drive that net zero or decarbonization of a particular building with our electric systems that we're using.
Yeah, so as a consulting engineer, we have a direct impact on how much energy the building consumes once it's actually built. Out of the energy a building consumes, only about 20% goes towards plug loads, which would be like plugging in your computers, charging your cell phones, so forth. The remainder 80% is a result of systems that we specify install, so lighting, HVAC, domestic hot water heating. So the more efficient we design those systems, the less energy that building is going to consume. So that's, I think it's a pretty big impact when you consider the amount of energy consumption that buildings take up across the world globally. So each building counts.
So building automation, like I talked about before, think of it as like an iPhone as a thermostat. It's like a microprocessor. So we control the heating and cooling systems that are designed. So take a room like this, right? It's like a conference room. So right now we're all in here. We want it to be nice 72 degrees. When no one's in here, we can increase the temperature 74, 75 to save energy. So these little microprocessors, we have sensors throughout the building. We sense temperature, pressure, occupancy sensors. What the lighting's doing. We take these inputs, right, these sensors, and have an output. And that sequence of operation creates an energy efficient building. So every building is different, has a different use. So what we do is we measure all those data points. We create like a graphical screen that you can see on your iPhone or a computer, so a building owner can say, yes, utilize that sequence of operation, or can override it, right? Today is, for a good example, is a snow day in a school. No one's in the school. So hit the snow day button, it goes into unoccupied mode. And everything that we do is easy to use, quick, and we can measure, we monitor a lot of meters, and so building owners can utilize that data. So energy and saving energy for a building owner is key, especially now with the new codes and making sure you're using less on the electrical side. Building automation is key for that. So energy is big for what we do.
I think in my role, the knowledge of new technology that makes equipment more efficient is important, because a lot of the times when we're trying to sell like a certain unit to like an owner, we work with owners as well, they don't really understand the efficiency component of it. And it's normally more efficient units are more expensive upfront, but you're getting more savings in the end because you're saving energy. And so for us, it's more of having that understanding of what the equipment is actually doing and how it's actually saving energy to explain to our customer why this is the way you want to go instead of going for maybe a cheaper product up front, but it's going to use more energy in the long run. So just being able to communicate the energy savings in the long run to our customer.
Is there any advice that you would give to these students beginning their college career, and maybe a lesson learned from college transitioning into the workforce? And I'll start with you, Brad, just to mix it up.
Yeah, jumping into the workforce, I would say if you can identify, and this is for your personal growth within the company, if you can identify a need within that company and you can niche down and become the expert or the go-to person within the company, it creates value there for your employer, or for yourself, for your employer. I guess I would highly advise trying to seek that out. In our industry, for example, either there's a gap in energy modelers. Like within our office, there's always a need for energy modelers. Say, hey, listen, I'll take that, I'll learn it, and I'll run with it. Or if you want to be one of the code guys, it doesn't mean you get stuck in that path. But you can become the go-to guy for that, and then it creates value for yourself. You'll see senior people start coming to you as the expert, and that's where you kind of find some sense of self-worth in your role, and it kind of builds your confidence. So I would niche down, find a need.
Anyone else?
Yeah, the biggest thing too is like I learned a lot more from my mistakes. Don't be afraid to fail, because sometimes you learn something from that. So I think try something new, like or be an expert, but don't be afraid. Oh, I don't know this. There might be someone who can add a resource, research, but don't be afraid to fail. Because I think in my career I've learned a lot from maybe making a mistake, and then gave me a path of now I know what I need to do. So that's something I wish when I came out of college I was so nervous about making sure everything was right, everything I did, and then when I found, I made a couple of mistakes, I've learned so much from those, more than my successes, I can say, in my career.
Yeah, I mean, going off of both of those things, be brave and don't be afraid to speak up. I think even walking around my own office, especially this time of year, we hire a lot of people right out of college, because May is when everyone graduates, we have a lot of interns come in, and the new folks that are just sitting at their desk with headphones in their ears for 8 hours a day, every day, they're just entrenched in just their task at hand. They're missing a whole lot around them. So don't be afraid to take those headphones off. Talk to the people around you. Put yourself out there. You'll never sound stupid. There's no dumb questions. I think for most of our companies, the day you start, they don't expect you to know a thing. So they want you to ask questions. They want you to learn. And just be brave. And the senior level people that are 5-10 years older than you, they'll notice if you're speaking up and you're taking initiative and really trying to put yourself out there.
Like I said earlier, I guess it's just really demoralized considering my struggles coming out of college, not knowing what I wanted to do, and it's talking to people who are also looking for jobs now. It really just comes down to what you truly want to do on your day-to-day. Like if you like being behind computers, if you like working with your hands, if you like talking to people, emphasize that to somebody that can give you exposure to opportunities to get a taste of what that actually feels like. So yeah, just understanding what you want to do every day, or like what you're comfortable doing every day, and then the type of concepts you like being around every day. So if you can find that out, definitely invest and explore those opportunities so you can see what the real world and like reality kind of looks like in terms of job opportunities.
How many of you on the panel had mentors throughout your college career and your professional career?
Yeah, I did. Having a mentor and a sponsor, someone that's going to promote you through your company, is very important. I was very lucky coming out of college. When I was hired by Carrie, I had a manager that wanted me to be better than what I had and taught me and put me underneath his wing. And probably, for 10 plus years, as he went to different companies, I went with him. That was very important for me because I got to see, learn from him and promote me, especially as a woman in the industry. That was big. But I think having a mentor and someone to bounce questions off of, or hey, this is what I'm seeing, is this okay? Having that someone you have that rapport with and having that great culture, that was key. And then someone that also sponsored me throughout my career, that was very important.
Okay, I'm gonna close with my last question, and then we'll open it up for you guys if you have any questions for the panel. Can anyone share a story related to a project that really inspired you and made an impact on your career? Anyone can start.
So when I started my career, there's a high school in Hartford. So we took it. It was the first one I really worked on, from like working with the engineer on the building automation design to fruition. And this, being able to see that project done and seeing all my hard work and actually being able to walk the building and seeing the sensors on the wall. I mean, my biggest thing, my phone is all pictures of thermostats. I mean, it's Honeywell ALC. I mean, so be able to see that and the wiring and seeing the systems work, right, the way they're supposed to, for me was really exciting. And that gave me that spark. I'm like, oh, I gotta do this again. Oh, I want to do, now we did this school, I want to do it in a college, or I want to do it in a hospital. So like for me, seeing that, the months of prep and, long nights, and seeing that, was all probably a 1.5 to 2 year process, right, from design to being completely done. That gave me the spark to keep going.
For me, being a UConn grad, we designed the UConn Student Recreation Center. So if you go up there, it's kind of diagonal across the street from Gamble. It has the lit up corner on the building, the cool lights. But that was the really first project in my mechanical engineering career where I was extremely nervous because friends and family all like UConn. I didn't want to mess that up, but it was a large project. It's almost 200,000 square feet and a couple $1 million of equipment that I was responsible for designing. And it was the first one where I had to sit in front of the owner group at UConn, and instead of somebody else explaining my design to them, like my boss explaining my design to them, I was the one explaining my design to them, and going back and forth with the facilities managers up at UConn, discussing alternatives to design. So that was a big opportunity for me, and it kind of helped me progress in my career where I took on more responsibility. From presentation skills and trying to communicate my thoughts to multiple user groups. So, and I'm proud of that work. It's cool when a company like this.
I'm still thinking of one. It's gonna be a while.
I'd probably say the knowledge that I have now, it's given me the perspective that construction, all these concepts will allow me to eventually build my own house, or be able to renovate to the extent that I want to, and I'll know how to gauge it and how to get it done. So just enlightening me to how I can apply my work to my own interests, and take advantage of that. And I feel like in your own discipline, maybe in mechanical, electrical, you'll learn how to do your own car work, or be able to repair your phone and without going to somebody and paying double. So using your knowledge and applying it to yourself and on your future endeavors and future interests, it definitely comes into play. So that's always exciting to see.